Okay, sorry about that, y'all. A little technical difficulty. Let's pick up where we left off. So I was saying that we have three graphs here, and here we're trying to see what effect changing the probability of success has on the shape of the graph. So for all three graphs, we have a fixed number of trials, but we're changing the probability of success progressively. Now, if the probability of success is 0.2, which is to say less than 0.5, then we end up with a right-tailed distribution. Okay, so a right-skewed or right-tailed distribution. If instead the probability was exactly 0.5, then we end up with a symmetric distribution, a bell-shaped distribution. And if instead the probability of success was very high, like 0.8, then we end up with a left-tailed or a left-skewed distribution. And in fact, this shape, this distribution shape is actually a mirror image of the case when it's 0.2. So notice that here P is 0.2, which is to say that 1 minus P is 0.8. And here P is 0.8, which is to say 1 minus P is 0.2. So these are sort of complementary images. And the distributions do work this way, that if we change out the probability of success for the probability of failure, then we sort of get the mirror image. But the main takeaway here is that when the probability of success is equal to 0.5, we get a perfectly symmetric distribution, whereas when it's less than 0.5, we get a right-tailed, and when it's greater than 0.5, we get a left-tailed distribution. So that's one trend that we see with the probability distributions. Now, we could, instead of changing the probability of success, we could fix the probability of success and instead let the number of trials steadily increase. Now, if that were the case, what we see to start with a small number of trials, we see that the distribution looks right-tailed. But as the number of trials increases, say to 50, still with the same probability of success, we end up with something that's working its way towards being symmetric. It's still got a long right tail, but it's getting more and more symmetric. And then finally, if we let the number of trials get really big, say like 100, we end up with something that's pretty dang symmetric. It's almost bell-shaped. So the idea here is if we fix the probability of success and allow the number of trials to increase, then as it gets bigger and bigger, as the number of trials get bigger and bigger, the distribution gets more and more bell-shaped. So this gives us the following rule of thumb. So if we have a fixed probability of success, then as the number of trials gets bigger and bigger and bigger, as in the number of trials approaches infinity, it gets really very big, then the binomial random variable X steadily approaches becoming bell-shaped. So as the number of trials gets bigger, the probability distribution gets more and more bell-shaped. And so the rule of thumb is that if we calculate n times p times 1 minus p, and that calculation gives us something that's greater than or equal to 10, then we say that the distribution of our random variable is approximately bell-shaped. So this is actually hidden here. This is actually the variance of the distribution, sigma x squared. So here we're saying if the variance is greater than or equal to 10, then our distribution is roughly bell-shaped. Okay. So this concludes chapter 6, section 2. We're talking about binomial random variables. Everything that we've covered here, you'll see in the homework. Calculating probabilities is the biggest thing, but some of these greater trends are important too. I will be getting your midterms hopefully graded by tonight and input by tonight or tomorrow, and I will post a solutions video for the for the midterm as a part of our next lecture. Okay. So I hope that helps. I hope everything's going well with everyone. Please send me an email if you need anything, and I will be in touch.